Brilliant Maths, where we teach maths with a passion. Continue to watch this channel. Subscribe to it. Go to the blog, brilliantmaths.com. You'll find exciting exercises that will help you. Tell a friend to tell a friend. Today we are continuing our lessons on circle theorems. But before we go into what we have for today, let's look at the answers to the last exercise. Question 1. We are supposed to find the values of angle E, F, and G. The value of angle E is 50 degrees because the same arc that sustains the angle that measures 50 degrees sustains angle E. F is equal to 45 degrees because you have the value of E to be 50, you have 85 degrees, and the sum of the angles in a triangle is equal to 180. So when you do that calculation, you'll find the value of F to be 45 degrees. And finally, G. G is equal to 45 degrees because the same angle subtends angle F and angle G in the same segment. So both of them are equal to 45 degrees. Question 2. In question 2, we are finding the values of X, Y, and Z. The value of angle X is 30 degrees. The value of angle Y is 78 degrees. The value of angle Z is 43 degrees. Question 3. We're just supposed to find the value of angle A. You use isosceles triangle property to find the base angles of the isosceles triangle. And then the same arc subtends A and one of the base angles, which is equal to 43 degrees. So A is equal to 43 degrees. Well done.
And action.
The theorem for today is a theorem that states that the opposite angles in a cyclic quadrilateral are supplementary. That means that when you add up the opposite angles in a cyclic quadrilateral, they should give you 180 degrees. So it means that if you add the value of angle B, the angle at B, and the angle at D, you should get 180 degrees. And if you add the value of the angle at A to the angle at C, you should also get 180 degrees. ABCD is a cyclic quadrilateral. What's a cyclic quadrilateral? It's just a quadrilateral in a circle. The corners of the quadrilateral touch the circumference of the circle. So that's what makes it a cyclic quadrilateral. And we need to prove that the angle at A plus the angle at C is equal to 180 degrees. And also the angle at B plus the angle at D is equal to 180 degrees. Let's try to prove this. To be able to prove this theorem, let's locate the center of the circle and draw a radius from the center to point A and another radius from the center to point C. So that's what we have. The angle at B is X and the angle at D is Y. Remember one of the theorems we've done before, that the angle subtended at the center is twice the angle at the circumference. So we say let ABC, the angle at B, ABC be equal to X, and let angle ADC be equal to Y. Then let's look at angle AOC obtuse. This is the angle AOC obtuse. From the theorem we know this angle is equal to 2x. The angle at the center is twice the angle at the circumference. Then we look at angle AOC reflex. If we look at angle AOC reflex, that's the angle at the center, and the angle at the circumference is y. So AOC reflex is equal to 2y. So that implies that 2x plus 2y is equal to 360. The angles at a point, it adds up to 360. So we have 2x plus 2y is equal to 360. If we divide each term by 2, 2x divided by 2 gives us x, 2y divided by 2 gives us y. Half of 360 is equal to 180. So we have been able to prove that x plus y is 180. That tells us that the angle at B plus the angle at D add up to 180, and that means that they are supplementary. In the same way, if we locate the center and we draw a radius from the center to B, to point B, and we draw another radius from the center to point D, we'll be able to prove that the angle at C and the angle at A add up to 180 degrees. That means they are supplementary. So that proves the theorem that says that the opposite angles in a cyclic quadrilateral are supplementary, or they add up to 180 degrees. Example 1. Find the values of A and B. We have a cyclic quadrilateral, and we're supposed to find the values of angle A and angle B. Based on the theorem we just proved, we learned that the opposite angles of a cyclic quadrilateral are supplementary. So we're saying that A plus 94 should add up to 180 degrees. So solution, angle A plus 94 degrees is equal to 180 degrees. And the reason is opposite angles of a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral. Angle A is equal to 180 degrees. Take away 94 degrees. 180 minus 94 is equal to 86 degrees. So angle A is equal to 86 degrees. For B, it follows the same method. Angle B is equal to 180 degrees minus 71 degrees, because B and 71 degrees are opposite angles of a cyclic quadrilateral, so they should add up to 180 degrees. So if you subtract 71 degrees from 180, you should get the value of angle B. So angle B is equal to, borrow 1 from 8 because we can't take 1 from 0, so it becomes 10. 10 take away 1 is 9. We have 7 left. 7 take away 7 is 0. And then 1. So the value of angle B is 109 degrees. And if you add 109 degrees to 71 degrees, you'll get 180 degrees. Example 2. Find the values of all the marked angles in the cyclic quadrilateral. So we're finding the value of P, 2Q, 3P, and Q. We know that in a cyclic quadrilateral, the opposite angles add up to 180 degrees. That means they are supplementary. So 3P and P add up to 180, and Q plus 2Q also adds up to 180. So let's use that to find the values. P plus 3P is equal to 180 degrees. The reason is opposite angles in a cyclic quadrilateral. So very good. We can then find the value of P and the value of 3P. We have that 4P is equal to 180 degrees. So P is equal to 180 degrees divided by 4. And to divide a number by 4, half it and half it again. So the value of P is equal to half of 180 degrees is 90 degrees. And half of 90 degrees is 45 degrees. So if P is 45 degrees, 3P will be equal to 45 degrees times 3. 45 degrees times 3. 3 times 5 is 15. Carry 1. 3 times 4 is 12 plus 1 is 13. So 3P is 135 degrees. And if you add up 45 degrees and 135 degrees, you get 180. Next is to find the value of Q. We know that Q plus 2Q is equal to 180 degrees. Same reason as the first one. Opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quad. So 3Q is equal to 180 degrees. Therefore, Q is equal to 180 divided by 3. That gives us 60 degrees. And if Q is 60 degrees, then 2Q is equal to 60 degrees times 2, which is equal to 120 degrees. So obviously, Q plus 2Q will give us 180 degrees. Having done these examples, I'd like you to try out the next set of questions. Question 1, the math angles. We're finding the value of x, y, and 2y in question 1. Question 2, we're finding the value of x, 4x, and y. Question 3, we're finding the value of x and y. My name is Ngozi Orevaoghene, a passionate maths teacher. Go to our blog, brilliantmaths.com. It's an exciting maths learning platform. Continue to watch this channel, subscribe to it, and always remember, the maths is fun and you can do it. All you need to do is give it a try.